Welcome to practice test B for section 5.1 and 5.2. 5.1, 5.2 practice test B, very similar to A. Directions on the front of the paper are to simplify down to a single term. So here, looking at this one, we've got a sine of alpha. Let's turn that cotan into cos over sine. And then that sine, of course, we can write as sine of alpha over 1. And we get a cancellation. So we're left with cos of alpha. And we're down to a single term. So that's probably the right answer. Now this one, of course, we can do it three different ways. We could turn cotan into cos over sine. We could turn tan into sine over cos. And they're going to cancel. Or we could leave the cotan alone and turn the tan into 1 over cotan. Same result. Or we could turn the cotan into 1 over tan and leave the tan alone. Same result. Equal to 1, no matter which way you slice it. Okay, this one looks like it's got a lot going on. Now I'm going to color code this. So this cosecant here would be 1 over sine of alpha. This secant is going to turn into 1 over cos of alpha. And then underneath both of those, we have this denominator cotan, and that is cos over sine. Now, because we're dividing fractions by fractions, let's take this up and flip it over. So now it is sine of theta over cos of theta. And on the diagonal, we can cancel the signs. And if we multiply what's left across the top, we'll have a 1. And then over here, we'll have cos times cos. That is cos squared. And 1 over cos squared is secant squared. Secant squared theta. Final answer, single term to a higher power. Oh, that just looks like a Pythagorean. Cosecant squared minus 1. That's just cotan squared. Cotan squared. I guess they're using t in that one. All right. Ooh, look at that. 1 over tan squared. Well, that's cotan squared of alpha. And then here we have a tan times a cotan. Well, again, just like that other problem, we can do this three different ways. I'm going to turn that cotan into 1 over tan. And then my tan I'll just write as tan of alpha over 1. So these are going to cancel, leaving a plus 1 here. And then we have cotan squared plus 1. Well, that's a Pythagorean identity. That is cosecant squared of alpha. And that is the front of practice test B. Now we're on to the back, where we're going to do verify the identity. So we will know the finish line here. When I look at my finish line on 34, it's just sine. So maybe I'm going to come over here and turn into sines and coses. Tan is sine over cos. Oops. Sine alpha over cos alpha. And then we have this cosecant down here. That's 1 over cos. And of course, we'll bring that up and flip it over. So now it's cos of alpha over 1, and we get that cancellation on the diagonal. And we're just left with sine is equal to sine. Okay, well, this is an easy one, a two-stepper. Numerator, tan squared plus 1. Well, that is secant squared by Pythagorean identity. And our denominator is also secant alpha. So we could do, again, subtract the exponents since we are dividing like bases. 2 minus 1 is 1. So this is equal to secant of alpha, which is our finish line. Congratulations, you made it. Okay, number 38 here, that 1 plus cotan squared. We have in those parentheses right here. Well, that's going to turn into cosecant squared of beta. And I'm going to put that over 1 because a real easy way to mop this up. This sine squared we can make as 1 over cosecant squared beta. And then we'll have a cancellation on the diagonal. Of course, we could have turned the cosecant squared here into 1 over sine squared, which would hit this sine squared over 1, and the result would be the same. Our answer is 1. And that concludes our second practice test. I hope you enjoyed it and you're ready for the test in class next time I see you.